Okay, so once again, thank you, Vincent, for joining, and sorry for this hiccup. And without further ado, please proceed.
Thank you very much, Iona. No problem for the hiccup. There's always something happening like this in the when we do not online conferences or seminars. So thank you again for the invitation. It's a great pleasure to be to intervene here in this seminar. As you mentioned, I'm going to talk about the GSVerif, that stands for Global States in ProVerif. So it's not a new work because it's been published in 2018. So there is, of course, a tool that goes with it that is called GSVerif, which is a front end to ProVerif. So this publication was done in collaboration with Véronique Cortier as well as Mathieu Turenne. So I know that last month, for those that have been following, there have been a talk by Bruno Blanchet in this seminar on ProVerif, in which he discussed some of the new features of ProVerif. In fact, we will see in this talk that some of those features were inspired by the work that we have done in GSVerif. So most of even though the GSVerif itself as a prototype remain as a prototypes until now, many of the ideas have been reused, and we are continuing reusing them. In fact, we have put in the team Alexandre Deban, that is, we'll be working on upgrading, revamping the tool so that it's become completely integrated to ProVerif and that is really usable. So, of small context to start. Of course, you all know that designing a protocol is hard, and this work focuses mostly on the protocol aspects of the verification to guarantee the absence of logical attacks. And so we are not going to look at the hardware or the primitives, and we're going to place ourselves within the Dolabio model, where an attacker can control the network, meaning that it can read, write, and intercept messages, but it does not use side channel or control or it cannot break, the cryptography. So it's definitely an abstraction there compared to models like computational models, but it allows to those abstractions that are still fair in some sense, allows to have much more automatization, and allows for the development of verification tool like GSVerif and ProVerif. So the security property that we're looking at, it's mostly the one that are already targeted by ProVerif, meaning the classical one like authentication and secrecy, which can be stated as a reachability properties, and also properties that are based on equivalence, which allows you to model anonymity, vote privacy, and linkability, and so on and so forth. So when I mentioned that the Dolabio model allows for automatization, in fact, if you look at the literature, there is a plethora of automated tool. And here, I'm pretty sure that the list is not exhaustive. So you can have the more famous one, ProVerif, Tamarin, ModernPA, more recent like DeepSec, and also, sorry for the noise, that was unexpected. Let me mute myself for a second. There we go. And also tools like AFA, Omega, SetPy that are more prototype based, but are still being developed. So even within this plethora of automated tool, we can still classify them. So you have first tool that focuses on bounded number of sessions, where typically their goal is to achieve some decision procedure within a restricted class of cryptographic primitives. And why the limit to bounded number of sessions is because as soon as you go to unbounded number of sessions, the problem of verification becomes undecidable, even for very basic cryptographic primitives. Still, there is a lot of tools, and including ProVerif, that allows you to do proofs. for unbounded number of sessions. But of course, you have some caveat like the tool may not terminate, and even in the case of ProVerif, it may also give you some false attacks. Still, within this class of tool, you can separate between push down button and interactive user tool, like Tamara and Sapik, where the user can actually help the tool for the proof by either introducing lemmas on axioms or really guiding the proof as it goes on. Whether tools like ProVerif, StatVerif, and so on, you just really put your model, press the button, and that's it. The proof is done. Or unfortunately, either it doesn't terminate or gives you a false attack, but you cannot really help the tool other than inputting your model. So why did we look at ProVerif in the first place? Because GSVerif is a front end typically to ProVerif, is because, well, ProVerif is one of the really state-of-the-art automated verifier. It's more than 20 years old, so it's very mature. In fact, I think its birthday, let's say, was 20 years was last year. So it's fairly easy to use, and as I mentioned, push down button, and it has a very large public. So here I mentioned more than 140 papers that's using ProVerif, but it's not exhaustive in a sense that's mostly Bruno, check on either Google Scholar or something like that to look at the paper that are using ProVerif. So definitely the list is not exhaustive. So it's very expressive, but as I mentioned, it's a problem that is undecidable. And so, of course, it may not terminate all yields of false attacks. And it's also very efficient. Like if you look at the all the examples of the that are included in the distribution, takes less than 10 minutes in total to be verified. But still, you may have some case studies like noise protocol frameworks or TLS that may require several days or week to be completed. Okay, so if I come back to the false attacks, so it's true that determining in general what kind of a false attack the tool ProVerif is going to give you is very difficult. But there's still a class of protocols or certain type of protocols that you can guess that ProVerif is going to suffer. And it's particularly the case for stateful protocols. So it's protocols where you require some memory or states, global state that are used within the different session of your protocol. The same thing for tables, protocol with tables, which tables in ProVerif, you can see it as a append-only memory cell. So you can already see it as a state. But also more generally, protocol with private channel, in some cases, this is not very well handled by ProVerif. And so GSVerif, originally in 2019, the goal was to improve how ProVerif would handle such a kind of a class of protocols, and in particular remove as much false attack as possible. Okay, so for those that have never seen ProVerif, so probably this is, if you follow the talk of Bruno, this is maybe redundant a bit, but just to give you an idea of the input, you can state your cryptographic primitive. I don't know if you see my mouse, by the way. I don't know if Zoom record the mouse. I will assume that yes. So you can input at the beginning here the symmetric encryption, where you can express the, here I put the symmetric encryption in this example, but any cryptographic primitive that you want, and you express the algebraic properties through an equational theory or rewriting system. And you express your process. So here it's a very simplified example of a YubiKey that I will come back later on. And once you have pressed your process through a process calculus, you can see it as typically a small programming language where you have cryptographic primitives. You can express the security properties that you want to satisfy. So here it's a correspondence query. It's a, if something happened, then something must have happened. And also the scenario at the end in which your security property must be satisfied. So how does ProVerif works? I'm going to really give you a very high level explanation, because I know that if you want a really more detail, it's better to check the talk of Bruno. And for this particular talk, we don't need to to enter really into the greedy detail. So particularly how the saturation work and everything, I will leave that for another time. So, but generally the general idea is that ProVerif will take your process and abstract it into a set of own clauses. So if you look at this process where it's just output of some encryption on a channel, several output like this, then this is abstracted into the attacker knows. So at is here represent the attacker predicate, the fact that an attacker knows some message. So without any precondition, the attacker can know the encryption of S by the pair key 1, key 2. Same thing for output of K1 by K and so on and so forth. Okay. Once all the protocol is abstracted into own clause, ProVerif will apply a saturation to simplify the clause and make them in a nice, simple form such that the verification on the query on those saturated clause is easy to check. And so that's this this cycle that consists of the ProVerif algorithm. But in general, the issue of false attacks come from the abstraction into own clauses. Saturation of own clauses is where the case of non-termination happens. So the saturation with respect to the initial own clauses is sound complete, but the abstraction to own clauses is only sound. It is not complete. Same thing for the verification. It is sound, but not complete. Okay. So how, why this abstraction leads to some false attacks? Well, here I'm going to give you the small example. And again, sorry for those that have seen the talk of Bruno. This is an example that I know he used, but it's very useful after that for GSVerif. So I'm going to use it again. So here's the talk example where you have two participants, A and B. B act, so here all the keys and the secrets are private. So S, K1, K2, and K are all private. B act as an oracle for decryption with the key K here. So the other you can give in any encryption by K would give you a plain text, but only once. On the other end, A send the encryption of S by the pair of key K1 and K2. It is a strange key, but let's assume it's a key. Also encryption of K1 by K and encryption of K2 by K. So here we are interested into the secrets of S. And even though the attacker can know K1 or K2 within one execution trace, he's not able to know both K1 and K2. And so in that case, he's not able to create the pair K1 and K2, which prevents him from knowing S. So why does ProVerif fail on such a small example? Well, if we come back to how ProVerif transformed the process into own clause, we have the clause, or here I already showed you the clause that corresponding to process A earlier, and the clause here represents the process B. It typically literally says that if the attacker knows an encryption of something, Y by K, then the attacker can know the plain text Y, okay? And you also have some own clauses that are related to the attacker power, the fact that the attacker, if he knows a key and some term and a key, he can encrypt. He can also decrypt if he knows the cipher as well as the private key associated to it, and then he can update the plain text. Same thing for pairs and so on and so forth. And so the soundness property of ProVerif guarantees that if attacker of S is not logically deducible from the set of own clauses, so if attacker of S at S is not deducible, then the secrecy of S in the semantic of ProVerif calculus is preserved. Okay, it's not an if and only if, it's just an if. Hence the false attacks, in the sense that if the attacker, ProVerif find derivation of at S, it does not necessarily mean that the secrecy of S is not preserved. And it's the case here. And the reason is that in own clauses, you lose the fact that in the fact that B, the decryption as an oracle can only be done once, because any own clauses can be used an arbitrary number of times in a derivation for arbitrary instantiation. And so if you try it from this set of own clauses, the initial one, to build the derivation, you can use this on clause 2 times, one to decipher attacker of K1 by K, one to decipher attacker of K2 by K, which give the attacker of K1, attacker of K2, which allows him to rebuild the key and derive S. So how do we help ProVerif, or let's say the old GSVerif version? Okay, so if we look at previous works that typically looked at states, how to include states in ProVerif, like StatVerif and SetPy, the idea was to, well, we know that the abstraction of into on clauses is not complete enough, then we will modify the clauses that are generated to add more information and change the way the resolution is done. Because that's typically the approach StatVerif and SetPy. The approach of GSVerif, the old version, was to, in fact, augment the protocol with events to record some information. So the abstraction to on clauses remain the same. So we just modify the initial protocol with events. So this way, it doesn't change how the protocol behaves. We just add events. And we change the query phi, let's say, into, and this is kind of the strange part, phi or something or else false. So here, the phi or something or else false, it's easy to see that, of course, it is equivalent to phi. Why it's very helpful to ProVerif, it's something that we're going to discuss. But that's the general idea of what we do in GSVerif, and also why it explains as why GSVerif is a front end, in a sense that we only modify the input process, only modify the input query. The rest is exactly the same as ProVerif. So we just provide a new file to ProVerif without modifying its algorithm. Okay, so let's go back to our example. So here we knew that in this example, the main problem was that the input, when it's abstracted into on clauses, can be reused. It behaves as if it can be used several times, whether in the semantic of the process, it should be only once. So we add an event to record some information about this input. And in particular, we add an event, here I called it unique, that said, well, technically the input should be done only once, and here's the value of this input. Okay. So if we think about what the semantic of ProVerif calculus gave us, is it ensures that the input can be executed only once per execution trace. So now if we try to rephrase this property with using the unique events, it gives us that the semantic of ProVerif calculus ensures that the event unique can be executed only once per execution trace. So if we formulate like a logical formula for a statement that is always true, that would be that if you have a trace where 2 event unique has been executed, then it means that in fact it was exactly the same events, they can only be once. And so the contents here, X and Y, must be equal. And this is true in all execution. And so if you remember the modification of the query, which was to modify the query here, it's attacker of S implies some false into attacker query phi or something always false. Here we put the negations, the attacker of S implies that you had 2 events, unique X and unique Y, and X is different from Y. So this typically is always false. But semantically, it is always false, so it's equivalent to the previous query. So if we summarize, we have those 2 queries that are equivalent in ProVerif semantics. So whether we prove the left one or the right one is exactly the same, we are both happy with both, but it's not equivalent in terms of ProVerif algorithm, because on the left side, ProVerif is going to be able to prove that query, but not on the right side. It's going to give you a cannot be proof. If it were to give you a false, then it means that there was a bug somewhere, but it cannot be proved. Okay, so why does it help? So when we put an event, slightly modified the way the translation of ProVerif is that it will add this event inside the own clause. So the clause now that represents the process B is as follows. It says, okay, if the attacker knows encryption of Y and K and the event unique has been executed with the same value, then the attacker can know the plain text. And so if we retry to rebuild the derivation of S, we have that the previous the derivation only works if we have the event uniques enc of K1K and unique of enc of K2K. And the theorem, the main soundness theorem of ProVerif tells you that if attacker of S is derivable in ProVerif semantic, then it exists a derivation of attacker of S where you can use where you only need to use the events from that are executed within the trace. And so here, typically, you can see that those two events, for this derivation to be correct, would need to be used in the trace, which is not possible. In terms of derivation, of saturation, sorry, ProVerif, the events are typically preserved within the saturation. And so after the saturation, we obtain such a saturated clause where you have, mean that the attacker of S as a conclusion and says that the attacker knows S provided that those two events have been executed. And so when it comes to verifying the query, what ProVerif does is that it will check all the query that are all the saturated query, only look at the one that matched the premise of the query. So here I just kept the one that was matching, so it's attacker of S. And it will prove, I will try to prove the conclusion of the query on the hypothesis of each clause that's finished by attacker of S. And here you can see that it works trivially because K1 and K2 are constant, or they are names, they are not variables. And so you do have two unique events here, those two, where the encryption is different in the two. And so here ProVerif will be able to prove true. Okay, so GSVerif in a nutshell, really the idea is you add inside the process some events to record more information that will be preserved through the own clause. It is strictly more precise than ProVerif because you only add events, and the saturation procedure is unchanged as well as the verification procedure ish. So here I put the ish in the verification procedure because in GSVerif we had to improve the verification procedure of ProVerif because it was not handling correctly the disjunction in the conclusion of a query. And so we improved how he would handle the disjunction. And in fact, that's the way we improved it is part of the new feature of the ProVerif. I don't think Bruno mentioned it because it was, well, really one of the features that are not as selling as the others, but it's part of those features. So the good thing, as I mentioned already, is that the soundness of GSVerif is really easy to check because you only look at the protocol of the process and you only look at the queries. So you don't need at all to think about the own clauses and all those stuff. It's really just transformation at the protocol level, which is also why if you look at the paper of GSVerif, the proof are extremely small because they are very simple, almost trivial most of the case. The problem is by not modifying the procedure of ProVerif, we added event into the process, which made the clause more complex. And so by making the clause more complex, we increase the chance of the saturation to not terminate. And that has been a problem where we're doing our benchmark in GSVerif in 2018, is that in some cases, a small tweak in the event would really lead to non-termination. So here, this is where we stopped in 2018, but what the work we have been doing here and partially the way we transform led to, in ProVerif, the introduction to lemma's axiomal restriction. Because to solve this problem, it's like, oh, we want to be able to apply, to modify how ProVerif in the saturation. The idea is that instead of modifying the query, is that taking our logical statement and applying them directly in the saturation procedure. And this is done now with axioms and lemmas and restrictions, which are basically correspondence queries, so logical statements. So restriction allows you to restrict the trace that you look when you verify your query, whether axioms are assumed, directly assumed by ProVerif, and then ProVerif try to prove in order the lemma you gave him, reusing the axiom and the previously proved lemma. But all of that is done also during the saturations. So it really allows you to apply directly your properties within the saturations. So note that axioms, because they are not proved by ProVerif, just assumed, it is important that when you write an axiom that you are sure that your statement is true for all traces of your protocol. So now, how do we help ProVerif in the new GSVerif? Is that we augment the protocol with the same event as before, but now instead of modifying the query, we add axioms. And as I mentioned, those axioms are applied during the saturation, which allows the termination, which allows it to terminate much more often. So if we come back to our example, now the axiom is really exactly the logical statement that I gave you. Unique X and unique Y implies X equal Y, okay? And the security query doesn't change. So as I mentioned, so we implemented this in the front end as a prototype, and it worked well. I will show you later the benchmark, but I would say that mostly what is important in the work of GSVerif is really the way we created the transformation, and always follow the same pattern of to solve cannot be proved. So every time we would do a case study, and we faced some cannot be proved, and the first thing was to check whether the derivation correspond to a real attack or not. And so you had to go through the derivation to see, okay, it's not proof, it's not false. Why this is a derivation, and why this derivation doesn't lead to a real attack. And if you're able to understand why it does not correspond to a real attack, it means that there is a property from the semantic that contradicts the derivation. Okay, and here the key point is to be able to extract what is this particular properties. And then the step was to translate this property into a correspondence property by adding evens and then translating that into an axiom or a lemma. Once you're able to do that, usually you get rid of this derivation and you repeat that until either you get a proof or you get an attack. And that's this process that's that I'm currently doing, that was born with GSVerif, that I keep using when I do a case study, even though I don't use directly GSVerif, and I will explain you a bit why it's still at the prototype level. But the idea behind GSVerif really follows this pattern. And so if you end up with a cannot be proved, I strongly suggest that you go through this to-do list. Okay, so if you can do everything by hand, what's the idea of GSVerif? Well, the idea of GSVerif is that, okay, it's nice that you have to go through derivation, you understand the semantic, but some of the properties are usually always the same. And also, you don't want for every case study to go through all this tedious process. It's good to solve problem, but it may be a bit, it's error prone because you add axiom and maybe also difficult to do. So the idea of GSVerif was to have generic transformation and axiom that applies to all protocol that satisfy some easy checks, like really syntactic check. So in the case of the example with the inputs, it was working because our event unique, we knew from the protocol it was not under replication, and so it was only executed once. But in fact, you can have a generic transformation for any input. You just add an name, a fresh name, that we call on occurrence, and you add this French name not a French name, into the event unique. So here now your event unique has two arguments, O and X. O act as a timestamp if you want, and X is still the content of the input. And now the semantic property that you can have is the fact that in your trace, you cannot have two distinct unique events with the same occurrence name. And so in terms of axiom, it translates into if you have two events with the same occurrence, then the input must be the same. Okay. In fact, in GSVerif, you also introduce similar transformation for private channels. So in the private channels, here we had the definition that says, okay, private channel that you know is not going to be revealed to the attacker. We can have very similar example as before, where instead of having an oracle that decrypts, you have a private channel and a token. So here you have an output on this private channel SC and a token. And either the token is given to that particular sub-process that output K1, or the token is given to that particular process that output K2. And you still have the output of on the public channel of S by K1, K2. So again, for the same reason, because in the apply pi, an output on the private is eaten. So it's only when you do internal communication between output and input, the output disappear. You cannot output token in both that subprocess and this subprocess. You have to choose one. And so the attacker can only learn either K1 or K2. And so here the semantic property, so here you can also have a derivation for the same reason, because the attacker will be able to derive K1 and K2, same problem of derivation, except that now we can't use the transformation as before, because here the value that is given is as input is always token. So it's not a problem. We can't use just the token, the unique property. However, here the semantic property that we have is the fact that, as I mentioned, in an internal communication, the outputs and input are eaten once they're executed, they disappear. And so if you were to assume that outputs and inputs are labeled, it means that and you look at all the communication pairs of label, input and output, they're always distinct with each other. And so if you encode those labels using fresh name like occurrence, and so when you output not just the token, but as well as the label of the outputs, meaning that when you input, you have the label of the output, and as well as the occurrence representing the label of the input. Oh, here, sorry, it should have been O1 and not ST1. Then you have the semantic property that says that event communication, if you have two event communication, so representing the output input label or occurrence, then if you have the two input label that are equal, then necessarily it's equivalent to the two input label are equal, and vice versa. So this semantic property, you cannot directly write it as an axiom because we don't have the equivalence, we don't have the equivalence symbol in ProVerif, but you can encode it into two different axioms. Okay. Okay, so so here it was really, but I show you those two transformation are really generic and applies to almost any protocol without any checks, almost. Something more tricky, but much more useful is the use of memory cell. So as I mentioned, ProVerif calculus is stateless originally, but we can use private channel to encode memory cell. So in a OCaml version, the initialization of a memory cell is just, let's say, ref 0. The reading is using the bang X, and the writing is just you write the new value inside X. Okay. Well, in ProVerif, what you can do is use a private channel, define a private channel here, cell that represents the X, typically the memory cell. The input is, the initialization, sorry, is an output of the value 0 on this cell. And then the reading is just your input on this private channel to receive the current value and directly output it. And the reading is you input the current value and you output the new value. So why we have this always input output is, again, because of the property in ProVerif where the internal communication are synchronous, and meaning that when you do an output and an input, it's both input and output. And so typically there is always one single output available at all time. And the value of this output represent the current value of the memory cell. Okay. So something interesting with memory cell is the fact that because to be able to do an input, you need an output available. If you were to add something between the input and the outputs, both, let's say, in the reading and the writing, then you're kind of locking the information. Because imagine that you have this input, this initialization, and you use the reading to read 0. Okay, so here you've eaten output, and you're ready to execute event B. Normally, if it was not locking, you would say, oh, maybe I would start reading to writing, so I would try to input the memory cell. But then there's no directly available cell available because this one disappeared, and the only available one is the one on of the output of the reading X here. But it's not yet available because you haven't yet executed event B. So if you have elements between the input and output, you can see, in fact, an input as a lock and read. So you lock, it's like your cell has a lock on it as a mutex, and you can lock the mutex and read the value of your cell, execute what you want. And once you're right, once you do an output, is similar to a write and unlock. Okay, so in particular example here, you cannot have a sequence of event A, B, C is not possible. Okay, so this is something that is very useful to represent, because to represent memory cell in ProVerif, and also allows you to represent sequential protocol and something like this. So how do we use those memory cell in GSVerif? Well, let me take the simple example of YubiKey protocol. So it's a very simplified version. Okay. So here, typically, you have Q that represent the agent, like the small small YubiKey, and P represent the server. So both P and Q have their own memory cell. So cell P and cell Q. Q, typically every time the button is pressed on the key, you look at its current value. It will output this current value with a key K that is shared with the server and increase its own memory cell. Okay, so here's something that we can have, a property that we can have in the semantic is that we can see that the sequence of value that it takes the memory cell Q always strictly increase. Okay. Same thing for P. P typically receives some message on the public channel, read his current memory cell, and then he will decrypt what he received on the public channel and check whether or not the decryption, the plain text, is strictly bigger than the current value on the cell. If it is the case, he accepts the communication. It's typically to avoid replays, and update the value by putting the value that he received, or it just does not accept the communication and let his cell as it is, meaning he unlocked the cell. Okay, so here again we have a nice property that says, okay, the value of the cell are always going to be monotonous, not entirely strictly increasing, because here we have a case that we input some value and the value remains the same, but it's always monotonous. The good thing is that we can encode this property in GSVerif by, again, using axioms. So if we, and this is something that is already implemented in the prototype, not with axiom, but the idea is the same. So typically, we consider an event that represents the last time the cell has some value. So here's the new occurrence, new O event counter change OJ indicates that on at occurrence O, J is the last time the cell has that particular value J for monotonous memory cell. And so in P, we're going to put this when we are in the Zen branch, because we know that here that was the last time. Oh, sorry, here it should have been I and not J. And on the other end for Q here, we know that every time anyway, the value will change. So it is I. And so what we can do is state the axiom that says that the first one tells you that if the two occurrences are the same, then necessarily the content should be equal. So this is very similar to the unique axiom that I mentioned before, because they are related to the occurrence, because every time there's a fresh occurrence, so necessarily the value must be the same. But the interesting part is after, if the value of the counter are the same, then necessarily it must have been the same occurrence here. And this is interesting because when you have the same value, because you have the same occurrence, you're also forcing the same input previously, like the value of some constraint on X. And so it really simplifies, it really removes some of the fault derivation that ProVerif can take. Another kind of property that we also can consider, that this one is not implemented in GSVerif yet, but we are considering including it into the new version because it's something that occurred once in one of my case studies. And so again, GSVerif, the idea is to have a vast number of possible transformation so that you don't have to implement them yourself and you just pick and choose which one you want. And here the idea is that in the protocol, when we go from I and we update to J, because it's monotonous, we know that no other cell value must be between I and J, cannot be contained between I and J. So we can add an event interval that represents the forbidden value. So here's all the value between I and J strictly. And we record on the events, we record an event value cell P that just record all the possible value that are taken by the cell. And you can add an event that says, okay, if you have one event value X and an interval I, J, then necessarily X must be smaller than I or bigger than J. And again, it seems very simple transformation, very like, yes, of course, it's logical why ProVerif does not understand that directly, but it's transformation, especially with natural number. That's because a natural number in ProVerif encoding to PO representation like 0 or 6 or 6 or successor. This is the kind of property that becomes trivial for our as a human, but for ProVerif, it's something that it really cannot directly guess. So we have to add it ourselves within GSVerif. So what GSVerif does in terms of implementation, in fact, the old version is that it would take your file that you write as if it was a ProVerif file. You add an option precise on the channel. Then you would check what kind of a transformation you could apply on your channel, generate an output file, and you would run this output file with ProVerif. And if ProVerif would tell you it's true, then you're fine. Then you're fine. You finish your proof. Note that if you look at the current version of ProVerif, precise is used in a different way. So it's a bit what I mentioned, that some of the idea that the new feature of ProVerif came from GSVerif. In particular, we reuse the keyword precise, which, okay, now it's a bit not necessarily a good idea because it's kind of confusing. But here, the precise keyword was, it's different from the current precise keywords of ProVerif, and so we will change it in the new version of GSVerif. So here's the benchmark from the old GSVerif, and already, of course, we compared it with ProVerif, which was kind of an unfair comparison because we knew it would do better, but we applied it on several protocol. We compared with StatVerif, which is much older, one of the first protocol that tried to do states in ProVerif, and already was managing quite a lot of those protocol. We also looked at the comparison with Sampic and Tamarin. So here the square typically, because we insisted in the paper between the automated, fully automated, like what GSVerif was attempting, and Tamarin and Sampic, where you have to add those axioms and lemma by hand. Okay, you have to know what you add. And so most of those, the square here represented the fact that you needed to add yourself lemmas or axioms. But most of those work here are not paper not protocol that we tried ourselves. It was paper taken from the literature. So we also try with SetPy, but it was much more complicated. We had quite a lot of trouble to make them run. We found a couple of bugs, and also some of the model was not corresponding to the specification. So it didn't really go well with SetPy. So I'm almost at the end. So what the new GSVerif will allow? Well, one of the key interests when we wanted to improve GSVerif into the new ProVerif was to, of course, remove a lot of the termination problem, but also to be able to apply our transformation to injective correspondence queries and as well as equivalence properties. And equivalence property, you cannot have those correspondence queries. So that's why we introduce axioms and lemma into ProVerif. And the good thing is that all our transformation that I describe here and that are contained in the GSVerif paper can be expressed for axioms on equivalence properties. You have to, it's not exactly the same syntax, but it also works. So we are able to have proof for equivalence properties, also injective correspondence queries. Something that we are going to do in the new GSVerif is to really have a full integration with ProVerif. So it's now not going to be two different tools. They're going to be coming directly from ProVerif on the same package, so that we can better maintain it and also really no duplication of code, and as well as to be able to really use them for all the kind of queries that ProVerif is able to check. And lastly, something we're really interested into doing is, so currently in GSVerif, we redo those syntactic checks, simple syntactic check to see if we can apply some transformation, which is nice, but the problem is that it's too coarse. It's too coarse in the sense that either ProVerif, GSVerif will apply all the transformation or none of them. And sometimes one of the reasons why I'm not even using myself GSVerif, just the ideas behind them, is the fact that when I work on like a big case study like TLS 1.3 that is going to be published soon this year, that reuse most of the idea of GSVerif, I didn't use GSVerif because I need something much more precise. So we are trying to see how I can better fine-grain suggest transformation to the user so that it doesn't have to put them by hand because this is, again, error-prone, but at least that it can be much more fine-grained in terms of suggestion. Thank you for your attention. So if you have any question, feel free to, well, you can ask them now, of course, but also you can email us if you have, if you want to try, if you have a more specific question. Matthew is not more active recently on this particular project, but definitely Veronique, Alexandre, or myself will be more than happy to answer you. Of course, check out the website of ProVerif. And you can check also the website of GSVerif. It's a bit long, but if you just check GSVerif if you type GSVerif in Google, one of the first two links is going to be that particular website. Thank you very much.
Okay, so thank you, Vincent. We open the floor for questions. First questions that are still recorded, if you like, and then some off the record. Just tell me if you have an off the record question and I'll stop recording.
Sure.
Okay, Tom, go ahead.
Hi, yeah, it's a really nice talk. This is really good stuff. You mentioned equivalence properties briefly at the end. How's for checking if by simulation now? I realized some time ago I tried it out and different structured processes would really trip it up.
Yes. So currently the axioms, especially the axioms, apply. You write axiom for by processes. So when you try currently ProVerif with two processes that do not have the same structure, it's going to try to first transform them into a by process. And so in that case, by default, we remove the axiom that a user inputs, or you put a warning saying that be careful, because I mean, the transformation an action that was true before may not be true after the transformation, because the user doesn't have a full control about how ProVerif transforms. However, the good thing about the axioms that are here presented into GSVerif is that, in fact, all those axioms are specific to one process on, to a process on one side, and not on the by process itself. So all the transformation from GSVerif would apply on both sides of the equivalence, and so they would be safe, let's say, by transformation. So we will be able to have them even when you put two different two processes with different structure.
Okay, that sounds good. Thanks a lot.
Pascal?
Hello, can you hear me?
Yep.
Oh, thanks, Vincent, for the talk. Did you perform a performance evaluation between ProVerif and GSVerif on an example where they can be compared?
It depends what you mean by example that can be compared, because if ProVerif was already answering true or false, then applying GSVerif does not have really any meaning. You can apply it if you want, but it doesn't add anything. So the idea the workflow when you use GSVerif is really you write your normal ProVerif, you apply it, and if ProVerif is not able to answer correctly, then you start adding some precise into GSVerif, hoping that it will lead to true or false, but not, it cannot be proved. Okay, so comparing ProVerif and GSVerif, it's not.
I don't know if you can have some example where you can add the precise and find something that is terminating or something.
Oh yeah, so I mean in general,
my idea is to say, because it will be integrated in ProVerif, so you increase the semantic of ProVerif, but is there a mechanism that will be allowed to, if ProVerif fail, you don't put everything to the trash, we use the computation and go further with some precise somewhere or something like that? Oh,
no, I think, okay, I see what you mean. So the idea that, what would be possible, my hope is that if the transformation of ProVerif fails, then we can, ProVerif can use the derivation that led to the false derivation, leading to the false attack, to guess what is the best transformation to apply, and then retry with that particular transformation. But you cannot reuse the saturation procedure, because you would need to recreate the clause with a new event, something like this, and then resaturate. So you can reuse the derivation, and that's the hope that we are trying to achieve, to guess what is the correct transformation. But once you know the transformation, you have to throw away what has been done before and retry.
Okay. When will be the merge?
We are working on it. So normally the implementation should not take too long, because most of the transformation are there. But at the same time, we're writing the journal paper and trying to, make the transformation as smooth and more. So we are interested also to have some feedback. So maybe we would release some kind of a beta version or alpha version to see whether or not some features that we add are useful for a user, because sometimes we're using with Veronique, with me, with Alexandre, but we may not be the best, or even Bruno, but we may not be the best user sample to see if something is useful or not for normal user, I would say.
Okay, thank you very much.
Okay, I have a question that follows on from release and such things. So you had a slide with different protocols, YubiKey, mobile, EMV, different things. Yeah. These were checked with the old GSVerif.
Right.
But if I go to the WellDocs website for old GSVerif, your 2018 paper or so, I can't find any of the examples in the repository. Are the examples available still?
Yes, they were. I think they were on the web. Okay, the web page were not. If I recall, they were really at the bottom, and I say this is the benchmark that we use.
Okay.
Let me try to find.
I went to the. Well, don't worry. I can also find. I went to the GitLab repo where the.
Oh no, the GitLab repo was really just the implementation, and should be on the website if my internet allows me.
That's all right. It can't be worse than one of us setting YouTube with one account from one seminar and the other setting Zoom with another seminar and not being able to.
I don't know. The site Google doesn't want to run, so probably. But normally it's on the web page. It's on the benchmark something, so it's should be there.
Yeah, installation.
But
yeah, I will find
benchmark indeed.
No, because it's also interesting. There's some protocols in there that will be interesting to also compare even outside of GSVerif to have a look at how they've been modeled and potentially.
But especially for SAPIC and Tamarind, because it was really a different kind of. We used the interface SAPIC, so we tried to be as fair as possible in the sense that we look at example that was already coming from the literature so that we don't have to touch them. And also for those that were not coming from the literature, we try to write the process in the spirit of what the author of the tool were previously doing, assuming that the way they were implementing or coding was the best way for the tool. Mm-hmm. Because otherwise, if you write something that works well for one tool, but in another tool, if you write in a certain way, it's not going to be good, then the comparison is a bit unfair.
Okay, thanks for that. That makes sense. I have one more question, but I'll wait to see if anyone else. I have to look at my participants. If everyone else has a question, Pascal has another question.
Yes, there is SAPIC Plus who just came out. Do you have a comparison with this one or not?
Yes, so SAPIC Plus typically currently, so SAPIC Plus, I'm also part of the co-author of SAPIC Plus. And the idea is that now SAPIC Plus translate both to Tamarind and to ProVerif. And in fact, it translates to GSVerif. So, so that currently, if you go to the website of GSVerif, it's still not the really new version of GSVerif because we're currently working on it. But it was a version that I released, I think, last year or beginning of this year, where I already use axioms rather than transformational queries, and I added small features. So currently, SAPIC Plus typically transform into GSVerif. So if you don't even need to use GSVerif, you still need to use the GSVerif, but you can already write your model in SAPIC Plus and translate it into Boost, Tamarind, or ProVerif.
Thanks.
Okay, so this is my last question, and the question that I have is, okay, so there's some very interesting things about statefulness and invariance that you can do in GSVerif. And you've already answered the question to Tom Chotia about diff equivalence and by processes and how this could work in there as well. Is there any plan to take something like this and put it also in DeepSec for trace equivalence properties, or not at all? So trace equivalence properties with some statefulness. And...
so in DeepSec, it's not really useful. I mean, it could be maybe useful for improving the speed of verification, but not for soundness or completeness, because DeepSec has already been proven to be sound complete. So you can already use, write, put stateful protocol by using exactly some coding into DeepSec, because you're allowed to have private channel and everything, and it will completely work. That's not a problem. So DeepSec is already stateful if you think in that sense.
Then it's
it's true that DeepSec with respect to ProVerif is that much slower because it explores everything. So maybe axioms or like this kind of technique could improve the speed, but yeah, it could be interesting to investigate.
Yeah, but it was my misunderstanding because I didn't know that you can have statefulness in there.
Yeah.
Okay, so that's all the questions for now. Anyone else? No one else, in which case, on behalf of everyone that's organizing this seminars, I'd like to thank you, Vincent, thank you everyone who participated, and I'm sorry for the hiccup. We will put the recording online anyway. And I shall see you all from the FMSec in nearly a month, actually 3 weeks. Yeah, we'll have probably a talk on Squirrel.
Nice. Thank you very much.
Thank you all. Bye.
Bye.